Alright, so today we're going to look at solving quadratics. There are four methods that we can use to solve quadratics. One is square rooting. Second one is by factoring. Third one is completing the square. And the fourth one is the quadratic formula. Now, you can always use the fourth one. You can always use the quadratic formula to solve a quadratic equation. And the third one as well, completing the square. Both of those are methods that could work for every single problem. But they are the two most probably complex ways to solve. So one of the ideas and strategies we're going to talk about during this video is when do I use each one? When is it better to use one versus the other? So you can try to pick off and kind of go in order of what to do. So first one, square rooting. Big idea with square rooting is that the only variable in the problem can be an x squared. So it can't be 3x squared plus 4x equals. It only can be like 3x squared equals some number. So they can only be the x squared. So that's kind of a big piece with that. So if you see a problem that only has an x squared in it, you really want to use square rooting. If you use one of the other methods, you're really making it kind of harder for yourself and a lot more work. Second method is factoring. This method works really, really well if you know how to factor. So you want to be really proficient on how to factor quadratics. Again, if you can factor quickly, this is a very easy method to use, but you got to be able to factor to do it. The second key thing with factoring is it has to be equal to 0. So in order to use the factoring method, you have to set your equation equal to 0 first. And the other part that's with factoring is not all problems are factorable. So if you can't factor the quadratic, if you can't find that product sum, two numbers that multiply the product and add to the sum, then this method isn't going to work. So one of the problems with factoring is it doesn't work all the time. But again, if you can do it well and do it quickly, you'll find out that it's a really nice method for the problems that it works with. Third method is completing the square. As I mentioned in the completing the square video, a lot of kids like this method because it really makes the problem easier. They don't get stuck in this b squared minus 4ac kind of piece. Again, this works for everything. It does get a little bit complicated and add some fractions in there. So sometimes it's a nice method when there's no coefficient, leading coefficient on the x squared, or when you factor that out, it doesn't leave a fraction for the b term. And then lastly, the quadratic formula. Quadratic formula, again, will work on every single one. But again, we see a lot of sign errors in my years of teaching. We see a lot of problems with the b squared minus 4ac part underneath the square root, the discriminant. So you got to be really careful with it. This one's very similar to the factoring one in the fact that you have to get this thing equal to 0. So what I'm going to try to do is I'm going to try to walk through a few different problems. Some of them I'm going to do multiple ways so you can kind of see different methods and which one kind of works for them. And some of them I'm only going to do one way because this is just the best way to kind of tackle this problem. All right, so example 1. We're going to look at the equation 4x squared equals 8. Well, when I look at this, I see right away that I see an x squared in it, but I don't see any x term. So that's going to tell me right away I want to use this square rooting method. In order to do the square rooting method, I need to get the x squared by itself. So I need to isolate the x squared. Right now I've got 4 times x squared. So what I want to do is I want to divide by 4, just like I would if I was solving a nice linear equation. That's going to leave me with x squared equals 2. Now here comes the tricky part. When you get rid of the x squared, the opposite of squaring something is square rooting. They're inverse operations. I'm going to square root. But the key thing, there's always two numbers that when you square them, give you 2. One would be the positive and one would be the negative. So when you take the square root of the right side, just slide this 2 over a little bit. When I take the square root of 2, I need to put a plus or minus in front of it to get my two answers. Very, very important, very common mistake that we see. Square root and the x squared, they'll cancel, leave me with x. And the square root of 2, I don't know what that is. I can't simplify that at all, so I'm just going to leave it as the square root of 2. So my two answers would be plus or minus the square root of 2. Okay? So there you go. That's how you would solve a quadratic that only has an x squared in it. Isolate the x squared. Maybe you had 4x squared plus 3 equals 8. Then I would want to minus the 3 first, then divide by 4. Again, just treat it like it's a linear piece first before you square root it. But do not forget plus or minus. All right, example 2. X squared minus 6x equals negative 5. Here I notice I have an x squared and an x term. So that automatically rules out the easiest method, the square rooting method. Okay? So next thing I'm going to try is, well, maybe I can factor this. Okay? In order to factor it, if you remember from that first page of your notes, you have to get it equal to 0. So I'm going to add 5 to both sides to set this thing equal to 0. Okay. Well, on this left side, there is no constant term. So there's not like a spot that I'm adding 5 to. I could think about this, that it was x squared minus 6x plus 0. Okay. But I can only add 5 to other constants, not to the x or the x squared. So I'm left with x squared minus 6x plus 5 equals 0. All right, now I'm going to try to factor it. Product, sum, two numbers, that whole piece. Again, go back to the video if you're not sure how to factor. It factors into x minus 5 and x minus 1. All right, once I have it factored, basically it's saying this number times this number has to equal 0. Right? Or really what we're kind of saying is a times b equals 0, where a is x minus 5 and b is x minus 1. Well, the only way for two numbers to multiply together and end up equaling 0 is if either a is 0 or b is 0. So that's what we're going to do. We're going to simply set each factor equal to 0 and solve. So I get x minus 5 equals 0 and x minus 1 equals 0. And then these are simple one-step linear equations. Add 5. So I get x equals 5. Add 1. So I get x equals 1. And there are my two answers. X equals 5 and x equals 1. Okay? So that means if I plug them back in, they should work. 5 squared is 25 minus 6 times 5 is 30. So 25 minus 30 is negative 5. Check. Try 1. 1 squared is 1. Minus 6 times 1 is negative 6. So I got 1 minus the 6 equals negative 5. So again, both of them check. And you really want to start getting in the habit of kind of checking your answers. One, to kind of make sure you're right. But as we get further into this course, you're going to see some times where those numbers actually don't work. So kind of get used to it now. All right, I'm going to do this same problem two other ways and kind of show you how this would work out. All right, if I wanted to complete the square to solve this problem, okay, which isn't a bad method to do here, I'm actually don't need to get it equal to 0. I'm going to actually leave it just as is. Okay. And remember, to complete the square, we have to find a perfect square trinomial for this. So I get x squared minus 6x. To again find this piece, I'm going to take half of b and square it. So negative 6 divided by 2 squared is 9. Now, here's the interesting difference to this. I have an equal sign now. If you remember back to the video, we added 9 and therefore we subtracted 9. But really what I did mathematically here is I added 9 to the left side of the equation, so therefore I must add 9 to the right side. Properties of equality keep the equation balanced. So I have a plus 9 here and a plus 9 there. Alright, continuing on then, this becomes a binomial squared. And again, I find this part by taking half of the b, so minus 3 equals negative 5 plus 9 is 4. Now I've got x minus 3 squared. I'm kind of back to I only have one x in it. So what I want to do is square root this problem to get rid of the square. Just like in the last one I did, I need to put a plus or a minus on the right side. The square root and the square cancel, leave me with x minus 3. And the square root of 4, I do know. I can actually rewrite that. That's 2. So this is plus or minus 2. Okay, so I'm going to get two answers. X minus 3 either equals plus or minus 2. Okay. That means x minus 3 equals 2, or x minus 3 equals negative 2. So here's how I'm setting up my problem to get my two answers. Well, x minus 3 equals 2, add 3. So there's x equals 5. We had that one before. Add 3 here. Negative 2 plus 3 is 1. And there we go again. X equals 5 and x equals 1. It's a pretty bad 5. Okay. Same two answers. So this was completing the square. We kind of left the negative 5 over there. Made this a perfect square trinomial by using the completing the square method. Cut the negative 6 in half and squared it. Since there was an equal sign in it, I was able to use properties of equality. Add 9 here, add 9 there. Now it's a nice problem that only has a single x in it, so now I can actually kind of use that square rooting method. So I square rooted both sides. Just careful with the plus or minus. This one actually simplified. I knew the square root of 4 because it's a perfect square. Got plus or minus 2, set up my two equations to get my two answers. Okay. Alright. One more time on this same problem. So the last method I'm going to use is the quadratic formula. As you saw from the notes at the beginning, that has to be set equal to 0 like factoring was. And now I'm going to use the quadratic formula. Quadratic formula you should know is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. There's songs to like Yankee Doodle Dandy and other things to remember this. I don't want to hurt your ears by attempting to sing. Okay? But x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, so a big division bar. Now we just need to substitute things in. Remember, we had ax squared plus bx plus c. So it says to take the opposite of b. Well, b is negative 6, so the opposite of negative 6 is 6. Plus or minus square root of b squared, so b is negative 6. Notice how when I substitute something in, I use parentheses. Minus 4 times a, coefficient on x squared is 1. And c is positive 5. All over 2 times a, which was 1. Alright, so I get 6 plus or minus square root. Here's where I need to do the math. Negative 6 squared is 36. 4 times 1 times 5 is 20. So it's 36 minus 20 or 16. Over 2. Square root of 16 we know is 4. So I get 6 plus or minus 4 over 2. And now I got my two answers. 6 plus 4 is 10. Divided by 2 is 5. So I get x equals 5. And 6 minus 4 is 2. 2 divided by 2 is 1. And there I go again. I get x equals 5 and x equals 1. Okay. So again, quadratic formula will work for every time. You have to set it equal to 0 first. Again, you got to be very careful in here that you do the right math. Negative 6 squared is positive 36. And again, I would probably just look at this as 4 times 1 times 5. That's 20. So that's 36 minus 20, which is 16. Okay. Or you could make that 36 and think about this as negative 4 times 1 times 5, which is negative 20. So it'd be 36 and negative 20, which still makes 16. But I have used this negative kind of like a subtraction sign. Some of you might like to make this plus a negative. If that works for you, go ahead. Now I get 36 plus negative 20. That's 16 as well. So lots of ways to kind of get that same answer in there. Use your graphing calculator. It'll help as well. Punch it right in directly. All right. Notice all three of those methods, factoring, quadratic formula, completing the square, all gave me the same answers of 5 and 1. It's just kind of a choice of what you like the best. All right, let's look at another example. 2x squared minus 10x equals 2x plus 2. All right, so first thing I'm going to do with this one, notice I've got an x squared and an x term, so square rooting is not going to work. So I'm going to maybe see if I can factor. So I'm going to try to get this thing equal to 0 first. So I'm going to subtract 2x. 2x squared minus 12x equals 2. Subtract 2. 2x squared minus 12x minus 2 equals 0. Alright, so now I'm going to try that product sum piece. Although actually I've got a 2 that I could maybe factor out from everything. So let's do that first. Let's pull out a 2. 2x squared minus 6x minus 1 equals 0. Alright, so let's try to factor this. Well, if I factor this, I have 1 times negative 1. So my product would be negative 1. And my sum would be negative 6. Well, the only way to multiply to negative 1 is 1 times negative 1. And that adds to 0, not to negative 6. What that means is this guy is not factorable. Okay, so I can't factor this problem. So that method's not going to work. Which really leaves me with either completing the square or using the quadratic formula. So I kind of got to start over a little bit. Well, to complete the square, I'm actually going to kind of start right back up here. I do want to bring the x's over to kind of combine the x's. Have to do that. Okay, but remember, I don't need it to be equal to 0. So to complete the square, what I'm going to do is I'm going to first factor out that 2. So pull out a 2. Leave me with x squared minus 6x plus something equals 2 plus something. So again, to find this, I'm going to take half of negative 6, which is negative 3, and square it, which is 9. So I get plus 9 there. Remember, as we saw in the other video, it's not 9 that I added. It's 2 times 9, because I'd have to distribute this. So really what I added to the left side was 18. So I have to add 18 to the right side. So I get 2 parentheses. This is going to be x minus 3. Again, taking half of the b value. Equals 2 plus 18 is 20. All right. So now I need to solve for x. Well, I've got x minus 3, that quantity squared, then times 2 equals 20. So the first thing I want to do is get rid of this 2. So I'm going to divide by 2. Then I get x minus 3 squared equals 10. Now to get rid of the square, I'm going to square root. Making sure I put in that plus or minus. The square root and the square cancel, leaving me with x minus 3 equals. 10 is not a perfect square, and there's no perfect square that goes into it, so I'm just going to leave that as square root of 10. So I get plus or minus the square root of 10. And I'm almost done. To solve for x, I need to add 3 to both sides. Alright, so when I do that, I get a final answer of x equals, well, I can't add 3 in the square root of 10, so I'm just going to put the 3 out in front. So I get 3, and then I have plus or minus the square root of 10. And that's your answers for this problem. The answers are either 3 plus the square root of 10 or 3 minus the square root of 10. If you want to write them as 2 separate ones, you can. I'm more than fine leaving them, as 3 plus or minus from the square root of 10. Okay. So that's how I go about solving this using completing the square. Again, I'm going to do this problem the second way, which is quadratic formula. All right, to solve this problem using the quadratic formula, I have to get it equal to 0 first. So I get 2x squared minus 14, minus, those aren't like terms, minus 12x minus 2 equals 0. Now quadratic formula. So x equals the opposite of b, so the opposite of negative 12 is 12, plus or minus the square root of b squared, so negative 12 squared, minus 4 times a, and a is 2, times c, which is negative 2, all over 2a, or 2 times 2. All right, so got to do some simplifying in here. Negative 12 squared is 144. Just going to do a little side math. Now again, remember we got a couple of options. We can ignore this minus and use it in a minute. 4 times 2 is 8. 8 times negative 4, or 8 times negative 2 is negative 16. Then it'd be minus negative 16, so it'd really be plus 16. Or if I thought about this as a plus a negative 4, it'd be negative 4 times 2 is negative 8. Negative 8 times negative 2 is positive 16. Either way I do this, this becomes plus 16. So 144 and 16 is 160. So this becomes 12 plus or minus the square root of 160 over 4. Okay? Now notice that doesn't look anything like our other answer. And the reason for that is this isn't simplified yet. So when I look at the square root of 160, what I'm going to notice in there is that 16 divides into it. 16 times 10 is 160. So again, I'm going to kind of do a little side work here. 160. Should have kind of done this a little bit before. If I break this down, 160 is 16 times 10. 16 is a perfect square. So I can think about this problem as the square root of 16 times the square root of 10, and the square root of 16 is 4. So I get 4 square roots of 10. So I can actually replace 160 with 4 square roots of 10, which I'm going to do. So I get x equals 12 plus or minus 4 square roots of 10 all over 4. And then what I'm going to notice is that 12, 4, and 4, not the 10, only the things outside of the square root, all of them are divisible by 4. Okay, so I'm going to actually kind of factor a 4 out of the top. I'm left with 3. 12 divided by 4 is 3, plus or minus 4 square root of 10 divided by 4 is just square root of 10. All over 4, and there we go, the 4's cancel, and we get that same answer we got by completing the square, but with a little bit less work to kind of finish it off. So I end up with that 3 plus or minus the square root of 10. Okay. So here's a problem I think couldn't work by square rooting, couldn't work by factoring. So I had to either complete the square or quadratic formula. I actually kind of like completing the square. It gives me kind of a nicer, cleaner answer to begin with. I don't have to kind of simplify it down. Up to you. All right, one last one. All right, so 7x squared plus 4x equals 3. Again, I got an x squared and an x, so square rooting is not going to work. So I'm going to try to factor, although this looks kind of ugly, so I'm not sure. So I'm going to subtract 3 to the other side. And then I look at my product and sum. Two numbers that multiply to a times c, so my product is negative 21. Sum is 4. So I need to find two numbers that multiply to negative 21 and add to 4. Well, 21 doesn't have a whole lot of options. 1 and 21. 2, no, because 21 is not even. 3, yep, 3 and 7. 4, no. 5, no. 6, no. Then I'm back to kind of 7. So that's it. Remember, as we mentioned, product's negative. So one of the numbers has to be negative. But it sums to a positive. Therefore, my bigger number is positive. So I'm going to put the negative on the smaller. And ooh, it actually does work. Negative 3 and 7. Negative 3 times 7 is negative 21. And negative 3 plus 7 is 4. So I've got my two numbers. So I'm going to split the middle term, 7x squared. I'm going to put 7x first. And minus 3x. And then minus 3 equals 0. Group. Be consistent on kind of what I did, so I'm going to group first two, the last two. I can factor out a 7x from 7x squared and 7x, so 7x comes out, leave me with x plus 1. First term's negative, so I'm going to pull out a negative, and 3 goes into both negative 3x and negative 3. Negative 3x divided by negative 3 is x. Negative 3 divided by negative 3 is 1. There we go. Remember, got to be the same. We did a good job. So one factor is x plus 1. The other factor is 7x minus 3. All right, so then, remember what we talked about is if you have two factors multiplied together equals 0, you can solve them by setting each factor to 0. So I'm going to kind of erase and jump back up here. So I'm going to set x plus 1 equal to 0 and 7x minus 3 equal to 0. X plus 1 equals 0, subtract 1. So x equals negative 1. 7x minus 3 equals 0, add 3. 7x equals 3, divide by 7. X equals 3 sevenths. That can't be reduced. There are my two answers. X equals negative 1 and x equals 3 sevenths. Okay. So this one actually worked. Factoring didn't kind of look like it initially. I kind of thought it wouldn't. Kind of just made it up, but actually could factor it to solve it. Okay. So come back. Let's try the other two methods on this and see how the quadratic formula and completing the square work for it. All right, so 7x squared plus 4x equals 3. If I'm going to do completing the square, right, I'm going to factor out the 7. Got to get this down to a coefficient of 1. Get x squared plus, how I find this is I have to take 4 and divide it by 7, so it's 4 sevenths. I'm going to be honest with you, right here I see this and I go, eek, this is pretty ugly. I probably would actually stop here and not continue with completing the square, but I will just for your sake. All right. So to find this, again, I have to take half of 4 sevenths. Well, 4 sevenths divided by 2 is 4 fourteenths. That can be reduced a little bit into 2 sevenths. Okay. Then I need to take that 2 sevenths and square it, which is 4 49ths. Again, if you're already kind of like, I don't want to see this, fast forward a little bit until I get to the solving it using the quadratic formula. All right, so remember, that doesn't mean I added 4/49ths. It meant I added 7 times 4/49ths. So I've got to take 7 times 4/49ths. Make that 7 over 1, cancel, 1 and 7. So I really added 4 7s. All right. Kind of trying to get somewhere. So I get 7 parentheses. This is going to be x plus. This is where I take half of this, which we just saw a minute ago was the 2 7s squared, equals, to add 3 and 4 7s, I need a common denominator of 7. So this becomes 21. So I get 21 plus 4 is 25 7s. Well, this actually might not work out too bad. All right, so what do I have to do from here? Well, I'm going to divide by the 7 first, or multiply by 1/7. That might look a little bit better here. Multiply by 1/7. That becomes 25 over 49. Those are both perfect squares, so that's going to make this problem a little bit nicer. Get rid of the square by square rooting. Don't forget the plus or minus. So I get x plus 2 7s equals square root of 25/49. So I can take the square root of 25, which is 5. Don't forget the plus or minus. I get 5 over, and the square root of 49 is 7. All right, so I get my two problems then. I get x plus 2 7s equals 5 7s, or x plus 2 7s equals negative 5 7s. All right, so first thing I'm going to do is I'm going to subtract 2 7s. And 5 7s minus 2 7s is 3 7s. I believe we saw that answer before. And same thing here, minus 2 7s. And negative 5 7s minus 2 7s is negative 7 7s, or negative 1. And those are the two answers I got. So, kind of was ugly for a while, a lot of fractions in there. Ended up being kind of a perfect square over here, so it didn't get as bad as kind of initially anticipated it to be, but still not the prettiest way. So this tough coefficient, when I pull that out and I end up getting a fraction here, a lot of times I might say, I just don't want to continue on with that completing the square method, and let's try the quadratic formula. Okay? All right, so let's look at quadratic formula with this. All right, so to solve quadratic formula, I'm going to subtract 3, get it equal to 0. So then x equals the opposite of b, so negative 4 plus or minus the square root, b squared, minus 4 times a, which is 7, times negative 3, all over 2 times a. Alright, so I get negative 4 plus or minus 4 squared is 16. Easiest math, maybe 7 times negative 3 is negative 21 times negative 4 is 84. So I get 16 plus 84. That's nice, that's 100. Okay. So it actually turned out nice here, which is going to have to turn out nice if I was able to factor it. So one of the things you'll notice and learn a little bit maybe as you go through is if I could solve it by factoring, what's inside my, underneath my square root, or what's called my discriminant, is going to be a perfect square number. All right, so let's finish this up. Negative 4 plus or minus the square root of 100 is 10 over 14. So I get negative 4 plus 10 over 14. Negative 4 plus 10 is 6. So I get 6 divided by 14. And 6 divided by 14 is 3/7. And my other one, I'm going to get negative 4 minus 14. Sorry. Negative 4 minus 10. I was jumping ahead of myself. And negative 4 minus 10 is negative 14. Divided by 14 is negative 1. So there's my 3/7 and negative 1.